Today's lesson will introduce the wrapper classes. Those are not, of course, the latest hip-hop classes. They are, in fact, the classes that allow us to use the primitive data types in Java as objects. So for this lesson, we'll go ahead and create a new Java project, which we'll call WrapperClasses. And add the word project to the end. Click Finish. Go ahead and disclose the contents of that project. Go to the src folder. Create a new class, which we will call our wrapper runner. And we'll give it a public static void main method. Click Finish. And this class will introduce the primitive type wrapper classes in Java. Okay, very short. This class will also be using an array list to get a little bit more practice with array lists. So let's start by giving ourselves some room to work here, and we'll go ahead and get rid of the console and the package explorer. All right, now we are ready to go. So first, for this particular lesson, what we're going to do is we're going to make a list that we can store a bunch of different kinds of objects in, and then later on we'll be printing that list and printing out the list based on what objects are actually in the list. So it'll give us a chance to see kind of polymorphism in action and an array list where we mix different things together. Just noticed I misspelled primitive. Let's fix that. Okay, so that means that we're going to need to start with a list, and because our list is going to store these primitive wrapper classes, and we're going to shove some strings in there, those objects all are in the object class, which we've rarely used, but we're going to use today. So we're going to make a list of object. Remember, that's how we pronounce this, because the thing inside the angle brackets is the contents of the list. So it's a list of object. All right, and then we're going to give the object, or the list, a name, the object a name. So I'm going to call it my object list. Okay, and then I'm going to call the constructor using the new keyword. And because it's a list, which is an interface, I need a concrete class to actually implement that list. I'm going to call the ArrayList constructor. And it's very important that the type here matches the type here. So I must use an array list of object. And then I'm going to go ahead and put my parentheses, because remember, I'm calling a constructor method. And if it's a method, I know that because it's got parentheses there. It's very easy to forget that this is actually calling a method in the ArrayList class. And the method it's calling is the default constructor. Now, because I haven't actually imported the list and ArrayList class, let's see if I can do that. I'm going to say, let's see, these should actually be above my java.comment. Import java.util.list. And I'm going to need to import java.util.ArrayList. Those are the two classes that I've just used, so we need to import them. And now all of my errors have gone away, and I'm ready to go. So I have just instantiated an array list object using the default constructor of the array list class. That's what that line of code does. All right, well, so what's our next step? Well, for our next step, we're going to start working with some wrapper classes. What is a wrapper class? Well, let's start by labeling what we're doing. We're going to say working with, and we're going to start working with the integer wrapper class. And it's important to understand that each Java primitive type, and what are the primitive types? The Java primitive types. And it's important to understand these are the AP subset types, because there are some others that we're not going to talk about. The Java primitive types are int, double, boolean, and that's pretty much it. So int, double, and boolean. I don't think I'm forgetting any. So that means that each of these has a wrapper class that represents this primitive class or primitive type as an object. Well, why would an object version of a primitive exist? And the short answer is this: I'm only allowed to store objects in an array list. What if I want to store an int value or a double value or a boolean value? How can I do that if they're not objects? And the answer is there is an object version of each one. Well, if there's an object version of each one, why don't we just use the object version? Why does the primitive version exist? The answer is generally because primitives are faster and they use less memory. And so we want to use primitives whenever it's feasible, and objects only when it becomes necessary, such as when we're storing them in a list or for a few other reasons. We'll also see that the object classes of the primitive types have some other special useful capabilities that we can leverage. So let's start with how do we construct or instantiate one of these classes. So we're going to use a standard instantiation of an integer using the default, or using the constructor. So what does that look like? Well, anytime I declare an object, I put the object type. Actually, anytime I declare a variable, I put the type, which is integer. So the wrapper class is basically the full name. So the wrapper version of an int is an integer. The wrapper version of a double is double with a capital D because it's an object. And for boolean, it's also boolean with a capital B. Okay, on the AP subset, only the integer and double classes are actually tested. So that's my type, and then I need a name for it. So I'm going to say this is an integer wrapper equals new integer, and then we have to give it a value. I'm going to give it the value 5. Okay, well, what can I do with this new integer that I've just instantiated? Well, how about if I add it to my list of objects? So I'm going to say my object list dot add an integer wrapper. Okay, so I've just used standard instantiation to construct an integer, and then I've added it to the list. Next, I'm going to go ahead and add a string to my object list. And what I'm going to add is a description of the thing that comes just before it in the list. So I'm going to say this is an integer instantiated through, instantiated normally using the constructor. Okay, so this is an integer instantiated normally using the constructor. So far, so good. It's fairly simple. Well, all right, so now I've got this integer object that I've just created. What if I need to use it as an int? For example, I'm going to write some code where I'm required to use this value as an int. How do I turn the object back into an int. And each wrapper class has a method that allows you to do that. So I could say int an int is equal to an integer wrapper dot int value. And what this does is this sort of unwraps the integer, the integer. Now, not unwrappers, unwraps. Well, there we go. Unwraps the integer. Now, I use this term. I made this up. This is not official. Don't think that this is an official term that you should use when talking to other programmers. But since an integer is a wrapper class, if I want to get at the value inside, seems like an apt description, I've unwrapped the integer. Okay? So I use the method dot int value, and for doubles it would be dot double value, and for booleans it would be dot boolean value, I believe. Okay, so next, what do we want to do? Well, this brings us to an interesting aspect of modern Java, which is that Java will actually go back and forth between the object version and the primitive version in most cases for you using something called auto boxing and unboxing. What is auto boxing and unboxing? Well, here I have an int primitive. What would happen if I tried to add that int to my list? So, for example, I'm going to say my object list dot add an int. And you should say, well, I can't add a primitive. You told me I wasn't allowed to add primitives to my list. This is a primitive. Only objects are allowed. So what's happening? Well, what is happening here is Java is auto boxing my primitive into an object. And in this case, well, actually, let's be specific, into an integer. My primitive int into an integer. So what's happened is I've just taken this int primitive, or rather Java has taken the int primitive, and it has automatically converted it into an integer and then added it to my list. So let's go ahead and say my object list dot add, or dot add, and then we're going to put this, and let's make this past tense. Java has auto boxed my primitive into an integer. Okay. All right, so far so good. So this is auto boxing. What does auto unboxing look like? Well, here I said an int is equal to, I declared an int, and then I said it was equal to, and I used int value. Well, what would happen if I just did int, another int, is equal to an integer wrapper? Strangely, I don't have an error. This should be giving me an error. How can a primitive be assigned the value of an object? And this is Java has unboxed my primitive int into, or actually unboxed my integer into an int primitive. Okay, and Java has done this helpfully without asking me. It's all automatic. Oh, and let's add using the .int value method. That's a really important little step there. This is very similar to how toString is used in Java. Remember when we want to take an object and we just simply print it out or try and use it in a context where it should be a string, Java automatically calls the toString method to convert the object into a string. Well, similarly, if we have a wrapper class and we try and use it as the primitive type, Java will call the dot whatever value method to convert it. So we're going to now add this to our list here. Add object, another int, and then I'll add a string, and we'll just use this comment here that we wrote to put that in there. Okay. So notice that my list is currently made up of integer objects and string objects mixed together. Okay, so what else do we have? Well, we also have in Java the ability to get some useful methods out of the integer class. So for example, I can find the largest and smallest possible value that can be stored in an int or integer. And the way I do that is by saying int smallest int equals integer dot min value. This would be the smallest integer I could possibly get. And here I've found the smallest value using integer dot min value. Okay, this is a public static final int. So this is what we would call a constant in Java. All right, so let's go ahead and add that to our list. All right, here we go. And this is going to be my smallest int. Now notice that I've once again relied on autoboxing to convert this primitive int into an object before I added it to my list. All right, and then we'll go ahead and add a string to go with it. And once again, we'll just take the comment and pop that in there. Okay, I'm going to give myself some spaces here so my code is further up towards the middle of the window. All right, and of course I could do the same thing to find the maximum value. So I'm going to do int largest. You know what, this time let's make it an actual integer object. So we're going to say integer largest integer equals integer dot max value. And once again, notice that this time I've used a different way of declaring my integer object. But once again, I'm relying on autoboxing to convert this into an object and then assign that to this integer. So this is constructing an integer by assignment, and it's relying on autoboxing to actually turn this into an object. It's a little tricky what's going on there in the background. There's a lot of detailed work being done by Java for me. All right, so I'm going to say my object list dot add largest integer, and then I'm going to say my object list dot add, and I didn't write a comment for that one, so I'm going to say largest value found using integer dot max value. Okay. All right, so we're almost through all of the methods. The last one is a nifty little method that will let me turn a number, a string rather, into a number. So if I want to say int what number is it equals, well, here, let's try this first. Let's make a string, equals 1, 2, 3. What number is it? Equals integer dot parseInt s. Now you have to be very careful with this method because while this may look to us like it could be a number, 1, 2, 3, what is Java going to make of this? So let's just go ahead and run our code real quick and let's see what Java does with it. And notice exception, Java language number format exception. This is the type of error or exception that you will get if you try to turn a string into a number, but it can't be turned into a number. Well, okay, what if it's partially a number? So let's make this 1, 2, and then 3. What will happen? Same thing. In other words, it has to actually be a number, and more importantly, so look, notice it ran that time without giving me an error, but what happens if I try and parse that into an integer? Once again, number format exception. I'm not allowed to have a decimal point in a number I'm trying to convert. So let's get rid of the decimal point. All right, so what number is it? And then let's go ahead and add that to the list. Object list.add. What number is it? And then my object list.add. This is a number created using integer dot parseInt string. Okay. All right, so those are all of the integer methods. Now what we have are the double class. So now we're going to see working with the double wrapper class. All right, at this time, I'd like you to go ahead and pause the video and see if you can add. You're going to go ahead and add a double using max value and string after it. This applies to all of these. Then we're going to add a double using min value. Then we're going to add a double using double dot parse double string. Okay, and then let's see, what else do we have? And then go ahead and add a double using standard instantiation. Instantiation. Okay, so do that now. Go ahead and pause the video. All right, hopefully you're back with me now and you've had a few minutes and you went ahead and did this. So let's go ahead and do this as quickly as we can. So here we go. We're going to do myObjectList.add, and then we're going to do double.maxValue. Oh, now, did it occur to you that you could do this with just one line of code? Notice here what's going to happen to this value. This is a double primitive, which then gets auto-boxed, which means it gets turned into a double object, and then that object gets added to the list. So there's several operations all happening together to make that one line of code possible. Then I go ahead and add my string, which will say, we'll just put in double using max value. Okay, and then we can do the same thing for our min value. All right, And then we're going to do my object list dot add and double using min value. Okay. And then we'll go ahead and we'll do a parsed string. So we'll do double dot parse double. Okay. Oops, I forgot a semicolon up there. And we want a string to go with that. Okay. So we'll go ahead and capture that comment. Make that our string. All right, and that brings us to our last one, my object list dot add new double 1, 2, 3, 4, 5, dot 6, 7, 8, 9. Okay. Now, in this case, remember this is what we call anonymous instantiation. I'm instantiating an object, but I'm not storing a reference to it anywhere but in my list. Okay, so next I've got my object list dot add and a double using standard instantiation. Okay. All right, so now we've got this exhaustive list. What are we going to do with it? Well, what we're going to do is we're going to count how many integers are in the list, how many doubles are in the list, and we're going to print out the contents of the list in a way that lets us print the type, what the value is, and then the label of how that value got put into the list. And we're going to do all of that using the new for each style loop. Okay? So we're going to start by writing our for each loop. And when we write a for each loop, we start with our for, put our brackets in. Now, what goes inside the parentheses? And what goes inside the parentheses is I am going to be going through my list. My list is a collection of some kind. What's the collection called? The collection is called my object list. Then I have to identify what is each element of this list. And I do that before a colon. And what things make up my list? Well, my list was declared as being made up of objects. So then I have to come up with a name for each object in my list. So I'm going to call it some object. Now, within my loop, some object is equal to my first object in the list, which was added way back up here at the top of the code. So it's going to be equal to an integer with the value 5. Then I'm going to scroll back down. So what do I want to do? Remember I said that I want to print the type value, and I'm going to say type and then colon value, then a space, and then the associated string. So how do I do that? Well, first I have to figure out what the type is. And there's a Java keyword for figuring out the type when you think you know what it might be. And it works like this. We say, if some object is an instance of, first we're going to see if it's an integer. If it is an integer, we're going to do a system.out.print, and then the word integer with a colon and a space, and that's it. Well, what if it's not that? What if some object is an instance of a double? Well, in that case, we're going to do a system.out.print that it's a double. Okay. An instance of returns true. Some object, why am I getting an error there? Oh, else if. I left off the keyword if. Okay, so what else do we need to do? Well, after we've printed that it's an integer or a double, next we're going to do a system.out.print of the actual object itself, followed by a space. And then, finally, we're going to do one last check. We're going to see if some object is oh, no, that's it. Oh, yes, we're going to do one last thing. If it's a string, we want to go to the next line. So, if some object is an instance of a string object, then we've already printed the string, so we just want to do a systemout.println to go to the next line. Now, what will my code look like when I run this? So I'm going to give myself some room here because there's going to be a lot printed. All right, so I run my code, and look, I get integer 5, an integer instantiated normally using the constructor. Integer 5, Java has autoboxed my primitive int into an integer. Here, integer negative, and that's a very large negative number, found the smallest value using integer.minValue. Here's my largest value. You might notice that the largest value goes up not quite as high on the number line as min value goes low on the number line, and that's because the number 0 takes up a position on the number line. So there's exactly half as many numbers on the positive and 0 side of the number line as there are on the negative side of the number line. Then we created 1, 2, 3, 4, 5 using integer.parseInt. Next, we wanted to know what the largest double we could have is, and notice that it is scientific notation. That is a very large number. And then we wanted the smallest number we could possibly have. Again, a very small number. And then we have a double that we created using parseDouble. Finally, we had a double that we created using standard instantiation. So in this lesson, we've learned about autoboxing. We've learned how we can use instance of to detect what kind of object is in a list or what kind of object an object actually is. We've also learned how to use the double and integer wrapper classes.